So we now move to the next question. Let's move to question B. And here we need to find out, so we need to find the decoupled equations of motion of the system, and in C, find the position x3 of the block number 3 for times t greater than 0. Right. That's really easy, and we actually have found out the answer to equation an answer to question B while doing question A. So here, so this. So for xi3 we have this equation. For xi1 can easily be verified that the equation of motion for xi1 is this, and for xi2 we have seen it before. Let me see where we have kept it. Yeah, this one, right? So this one's for xi2. M xi2 round out plus f minus k xi2. So all these three equations are uncoupled, and hence we have answer to question B. Now we need to find out x3 as a function of t when t is greater than 0. Basically, we need to find the evolution of the third block. For that, we can do one thing, that is, we can find xi1 as a function of time, xi2 as a function of time, and xi3 as a function of time. Then we can solve for x3 and express this thing as a function of x1. So it's xi1, xi2, and xi3. In this fashion, x3 will become a function of time, and we will be able to find the answer for C. Yeah. Right. So in order to find the size as function of time, what we need to do is we need to solve this three uncoupled differential equations. And notice these are linear differential equations with constant coefficients of variable 1. So these are really easy to solve, and if one uses simple techniques from introductory courses, mathematics courses, they can find xi1 to be, remember, if t here is fm cos of omega t, so xi1 would be minus f cos omega t by omega square plus c1 plus c2 x. Similarly, z2 would be minus f m cos of omega t by omega square minus k plus c1 cosine of root over k t divided by m plus c2 sine root k t divided by root m. And we have xi3 to be because of t by m omega square minus 3k plus c1 cosine of root 3 root k m root m t plus c2 sine 3 root k x t divided by m. Right? Now what we need to do is we need to solve x3 and express it as a function of the size. For that, we're going to use definitions of the size as a function of the axis, and that can easily be done. We're gonna use this thing. Right? So my bad. So we don't need this thing. We need the definitions of the we need the definitions of the normal coordinates. Yeah, I'm gonna use my memory and write that. So we had psi1 to be 1, 2, and 3, psi2 to be x1 minus 2x2 plus 3. I believe this is correct. Right, now we need to solve for x3 here. So so it can easily be done. So let's do it. I mean, you can find the inverse matrix and be done with it, or we just use any method from our childhood. So let's follow the simple path, and let's try to substitute. So we have x1 to be x3 plus psi2, so this thing comes out to be psi2 plus 2x3 plus x2, and this thing comes out to be psi 2 plus 2x3 minus 2x2. So multiply this thing with 2 and add it with this equation. Have this goes away, and we have as a result, x3 is written as 24 to psi1 x3. Right? So we all know the xi as a function of functions of t, and as a result, we know, technically know x3 as a function. All we need to do is we need to like plug in the values of psi1, psi2, and psi3 here, and we're done. Right? So this concludes our discussion. Hope to see you guys next video.